Hi, my name is Carl, and I'm going to talk to you all about how rocks can spontaneously combust. My decision to talk about this today was sort of based on my recent excursions into the hills of Altadena, where I've been exploring a lot of the abandoned mines in the area. And it's interesting because you get a rock that was recently exposed to Earth's atmosphere, present in some of the tunnels. So very interesting chemistry can occur under those conditions. Particularly the interaction between the gases from Earth's atmosphere and some of the sulfide minerals in these mines can cause spontaneous combustion. The reactions between sulfides and Earth's atmosphere don't only occur in mines, right? So the first time I actually learned about this was from this book, the Roadside Geology book for Southern California by the late Ert Sylvester and Libby Gans. So the first time I had actually dug into this book was after a trip I had done with my friends Sarah and Max out to the Cuyama Badlands, and we found a bunch of really wild orbicular rhyolite. And I was curious about what this book might have to say about Cuyama. So I went to that section, and as I was reading through it, I learned that spontaneous combustion in some of the shale beds out there, the sediment beds or whatever, can cause landslides to occur. And sometimes the temperatures get up to about maybe 520 degrees Celsius, which is pretty wild, So I was just like, wow, I did not know that. And but I've learned more about it since, and I'm going to talk to you a little more about that today. Another part of Southern California where you have rapid erosion and the exposure of sulfide minerals to Earth's atmosphere is Point Sal, right? And I found this chunk of pyrite there. See, it's kind of a shiny mineral. And what's going on there is the erosion of the sea cliffs is so fast that it's breaking down the rock more quickly than the pyrite can react, at least this pyrite. But the thing about the pyrite I'm showing you here is it's very, very coarse grained. The reason that this sample is not exploding in my hands right now is that the rock is not very permeable to Earth's atmosphere, so the reactions are only occurring on the surface. As opposed to, let's say I had something like this, but in a very, very fine powder, right? So what can happen under those conditions, and even other sulfide minerals, is that when you have something of a similar mass and it's very fine, you get a lot of surface area for these reactions to occur. And a lot of these sulfide atmosphere reactions are exothermic, so they release a lot of energy when the reaction goes to completion. And this is what happens in these areas, as you see fires, big fires, sometimes smoldering even. And there is a place that I actually have been where I've seen this reaction occur, right? And that is the Mesa volcano, or the Hope Ranch volcano. Feel free to Google it, but it's this neat part of the coastline near Santa Barbara where you have large sections of Monterey Shale that define sea cliffs. And there is this one part of the Monterey Shale near Hope Ranch where you can clearly see a landslide has recently occurred, and there's a bunch of smoke coming out of it. And occasionally you'll actually see flames. I think some of that may be due to the vegetation, but evidence suggests that a lot of that is just exposure of really fine-grained sulfide minerals to the atmosphere. And so in this picture here, you can see that there's actually smoke in this section. The red mineral here, which is most likely hematite and iron oxide, probably formed as a result of Earth's oxidizing atmosphere interacting with iron sulfides, like pyrite. But those iron sulfides were most likely quite fine-grained given the heat and the smoke and the fires that have occurred in this area. Just so you're aware too, the Hope Ranch volcano is not a real volcano in the sense that there's magma. It's mostly just these reactions between sulfide minerals and the atmosphere.